So now that we've completed our coverage of the basic features of CompletableFuture, let's start delving into some of the advanced features, beginning with the beginning, which are the factory methods. They're the ones that set the wheels in motion, as it were. If you recall in our intro from a few lessons ago, factory methods are what are used in the CompletableFutures framework to initiate asynchronous computations. And there are 4 factory methods that are used to initiate these. As I mentioned earlier, they fall into 2 pairs of 2. And the computations may or may not return a value. One pair of these methods returns a value, the supplyAsync variant. One pair of these does not return a value, the runAsync variant. So let's start first by talking about supplyAsync. And what this does is it allows two-way calls via a supplier. So if you take a look here, you can see the 2 methods, the 2 variants here in the supplyAsync family of factory methods. And the first variant takes a supplier, so that's the thing that the framework will use to get the computation that you want to perform when it needs to run it in a background thread in the worker pool. It returns a completable future that will have the result of the supplier when the computation is done, and it will go ahead and execute asynchronously in the common fork join pool. So the supplyAsync variant that just takes one parameter will execute in the common fork join pool, which is a good default to use. That's very much like the Java parallel streams framework. The second version of supplyAsync takes a supplier, which behaves the same as before, but it also takes an executor. And what this will do, it will asynchronously run the supplier in the designated or the given executor pool that's given. So there's typically a thread or threads that are part of that executor. And this allows you to define your own thread pool that gets used instead of the common fork join pool. But other than that, they work the same. And these are two-way operations because you're getting back a completable future that will ultimately give you back some result. Could be success, could be failure, could be the result of the computation, it could be an exception and whatnot. Now, supplyAsync takes a supplier, as you see here, and one of the consequences of doing this is you can actually not only get a value back, but you can also pass parameters, which is a little wonky at first. But the way you do it is by using the concept of effectively final variables. So you can see here that we have, in this particular case, 2 strings, F1 and F2. And what we're going to be doing is passing those strings as parameters to the supplier lambda that we're going to be giving to the supplyAsync factory method. You can read this link at the bottom of the page to learn more about what effectively final variables are. So we'll come back and talk a bit more about how this works when we look at the details of this. But as you can see here, what we're doing is we're going to pass in that supplier lambda. That will get queued up and run by some thread in this case, in the common fork join pool. And what we get back from supplyAsync is a completable future to the big fraction result. And then we'll see later how completion stage methods and other kinds of methods can be used in order to get those results without having to block the caller. runAsync is a variant of supplyAsync, which enables one-way calls via a runnable. So in this case, unlike the supplyAsync method, which took a supplier, in this case, we're going to have a runnable. And what happens here is that we're going to run the result or run the computation, and there will be no return value. So as you can see here, the first variant, which just takes a single runnable as a parameter, will run this runnable in the common fork join pool. And the second variant, which takes 2 parameters, the first of which is also a runnable, will run that runnable in the given executor pool, which is provided as the second parameter. So hopefully you get a sense of the kind of the parallel structure between supplyAsync and runAsync. They both give you the ability to run things in the background in either the common fork join pool or a designated pool, but the main difference is that you don't get a return value back from runAsync. Here's an example of how you could use runAsync. It's also doing big fraction multiplication. It's also passing in effectively final variables, just like the supplyAsync variant. But because there's no return value, if you want to get some output or some side effect, you have to do it in the means I show here. In this case, we're going to print the results out using the println method. So we'll multiply big fraction 1 by big fraction 2, and then print out the mixed string that comes back from that, and that'll just get printed to the standard output. This example is also illustrated in my EX8 folder. Remember that void is not a value, so there is no return. We just need to put the capital V void here as a placeholder for the Java type system, so it knows that there's a type, even though that type has no return value associated with it. And the only way you get results is through some kind of side effect. In practice, supplyAsync is used way more than runAsync. I'm honestly not even sure really why they have runAsync, quite frankly. I very rarely use it. I mean, I use it once in a while, but it's much more common to use supplyAsync. And the reason for that is that supplyAsync really is a nice segue into the whole concept of completion stage methods, which we're going to talk about here in just a moment. Once again, notice that in all the cases of supplyAsync and runAsync, the actual computation takes place in a thread pool, and that supports the reactive programming principle of elasticity because that pool can be mapped to multiple threads, or rather multiple cores. And by default, the common fork join pool is used, but if you want to provide your own pool, then you can do it. And that can either be one that comes out of the box, some other variant of a thread pool in Java, like cache thread pool or a fixed size thread pool, or even your own customized or implementation of fork join pool as opposed to the common fork join pool, or it can be some pool you implement yourself. So you have tremendous amount of leeway and discretion as far as where those computations will run. In contrast, Java's parallel streams framework, which we looked at for a number of lessons a while back, are really designed only to be used with the common fork join pool. So that gives us a bit more flexibility with completable futures in the sense that you can dictate or you can designate the given pool you want the computations to run in. So it's a bit more flexible, a bit more extensible than what you get with parallel streams. So that's the end of the factory method discussion. You'll need to know what a supplyAsync factory method is and how to use it. That will be crucially important for your programming assignment. And once you get your head around what it does, it really makes a difference in terms of the ability to start using the completable futures framework in earnest.